Hello everyone, I am going to finish your Unit 2 by graphing Quadratics' last target, but this time we're graphing with what we call vertex form. If you look at the equations here, they're in a different format than before. So we don't need to find an axis of symmetry. We don't need to find the intercepts. We already have a vertex screaming at us because in this format right here, this h inside the argument and this k is outside the argument, that will give us a vertex. We're going to treat everything else the same. So the a is still going to tell us whether there's a stretch or a shrink and whether it opens up or down. So let's start problem 2. A is a 2. So that means I know there's going to be a stretch. So when I'm counting my points, instead of using this 1, 3, 5 method we've used before, from point to point to point, we're going to have to multiply it by 2 because there's a stretch, so I'm going to have to use 2, count 6, count 10 in order to get what I need. I'm not going to be using the 1, 3, 5. So let's use the beauty of this equation here. Again, inside the argument and outside the argument tells us the vertex right off the bat is 3, 2. You notice that the sign says -3 inside the argument, but because it's inside the argument and we have to pull it out to use it, we have to use the opposite of what we see. So when we saw -3, we're using +3. If it's already outside the argument, you don't need to undo it, you just use it as is. So our vertex is over 3 up 2, let's label that. And then from there, all we need to do is count with that method, the difference between points over there. But remember, again, we said there was a stretch of 2 because the A was 2, so we know it's taller. So from our first vertex, we count up 2 and out 1, and then left 1. From that place, you're going to count 6 up, 1, 2, 3, 4, 5, 6, and up 1 more. And then because we already have a symmetry line here, this invisible folding line, this is 2 away, so this is 2 away. And there you have, very quickly, your parabola. We just need to label the points now so everybody understands. So let's just be cautious here. We had started at 3, but we went out 1 direction to 4, but we went up 2, so we stretched it, and then we balanced it on the other side. Over here, that's not a 2, is it? That's a 4. 4, 4, and 2, 4. I apologize. So you went from 2 here, and then you went up 2, so that's why it was 4, 4. And over here, it was 2, 4. From that 4, you went up 6, so there's your 10. From the 4, you went out 1. So let's do this here. We have a balance of 10. We went from 2 back 1, and there's your points. Again, it's balanced and it's folding and it's counting. If you get lost in this counting method that we used here, there's another method called the perfect squares, where you go out and up according to squares. And then there's just the traditional Algebra 1 method of making a table if you need to do that as well. Let's scroll down and do a practice again with this new form. Let's do 3. I like 3 because it has a negative in front. That's why I want to use that. So let's try the same order. So first off, we look at our A. It's a -1, so that means it opens down. Because it's a 1, I can use the 1 through 5 counting method. That'll be helpful. This format now gives me a vertex form, automatically used inside the argument, opposite what you see. Outside the argument's already done. So we're going to go over 4, down 3. Over 4, up 3, sorry. Okay, so let's just put it there. And then from there, because it opens downward, I'm going to count my 1 through 5 carefully. Down 1, over 1, down 1, back 1. From there, you go to the next one. 1, 2, 3, and over 1. And then from the same direction here on the other side, 1, 2, 3, back 1. Now we've got our parabola, nice and smooth. All we need to do now is just label the points. with coordinates so that we can see them, and then we are finished. So this guy to the left went to the left of 1, and then down 1, and then it balanced over here by going to the right 1 and balanced with the 2. Finishing on the right, you went from 5, 1 more over to 6, but from 2, you went down 3, so you ended up at -1. And then over here, you balanced it. From the x, you just went back 1, but from the 2, you went down 3, so you balanced with that -1 over here. Again, I'm just going to say, if you struggle with finding the points, you could just read the coordinates. If you struggle with finding them with this method, you could go back and use your XY table and literally start with the vertex and go a couple to the right and a couple behind, and then substitute those in and see what you get. It takes a little while to do, but it is accurate. You just got to be really careful with your substitution. Please reach out if you have any questions. We've now done all formats, standard, intercept, and this one is vertex form.